Hey guys, today we're going to be doing the add two numbers problem from LeetCode. You're given two non-empty linked lists representing two non-negative integers. The digits of these integers are stored in reverse order, and each of their nodes contains a single digit. And you have to add up the two numbers represented by these linked lists and return the sum as a linked list as well. Okay, the best way to see this really is the explanation. You have 342. So 342, and you're adding 465. Okay, and you're getting 708. Or sorry, getting 807. Yeah, the key is that the digits of each number are reversed. So you have 2, 4, 3, and then you'll have 5, 6, 4. And this is our L1. Actually, let's put that up here. L1 here. L2 there. Okay. Now, what did you do when you added these two numbers? Well, you probably looked at the least significant digits first and then added those, right? So you took the 2 and the 5 and you added them to be 7. Okay. Conveniently, our L1 and L2 are both pointing to the least significant digits of each number. So we can just add those directly, and that will give us our sum. But there's something we need to look out for. If there's a carry value, we also have to add that in. When we had the 4 and the 6 here and we added them, we actually got 10. So let's create some result. And it's just going to be an empty node. And we're going to take the sum of L1 and L2, and we'll just put it into this node. So 5 plus 2 is 7, right? But here, we're going to have 4 plus 6. So let's move our L1 and L2. So we're going to add L1 and L2 again. And we're going to get 10. So what do? We drop the 0 and we carry over the 1. Okay. Now we have to add the carry value in this time. When we add these two, we're going to do 4 plus 3, which is 7, plus 1, because we carried a value over. So we'll do 8. And this will be our answer, right? We'll just return result. Make sense? Okay, so yeah, the carriers are something to look out for. You should also be aware that if at the end, if you just have two numbers, 6 and 4, and you add these, our result is going to have a 0, and then a carry is going to exist. So we'll actually have to create a new node with that carry value in it. Okay, let's take a look at the code, which has disappeared. Oh, that's okay. I'm prepared. Let's copy this back. Okay, perfect. Okay, so we've gotten an idea of our algorithm. Now let's explain it in terms of code. We've got our carry, which is initially 0. And we're basically going to take each digit of L1 and L2 and add them together, but also include the carry. We'll keep track of the carry outside of our while loop. We're going to set a root node to be an empty list to start. So down here, we just, this is basically the same thing as our result. It's just going to be called our root, as in the end, we're going to return something relative to it. And we're going to have n, because n is going to be needed so we can like keep track of where we're adding nodes and then you know, chaining the list together. Okay, so here our main while loop is gonna basically say, okay, as long as we have L1 or L2 or a carry, then we have a digit that we're gonna add to our result linked list. So let's assume that we don't know which one of these exists. So let's set the values of L1 and L2 to be 0 to start. Because remember, you could have one linked list be longer than the other. L1 could be 42 and L2 could be 5, which means when you hit this 4, this 6 wouldn't exist, which means you would be adding 4 and 0. So let's set these two to be 0. And then if L1 actually exists, then we set V1, value 1, to be that value, which is 2. And then we'll move L1 like we were doing before. So we'll just go through this. Okay. So we've set V1 here. V1 is 2. Okay. Technically L2 is still back here. Let's just go through this step by step. Okay. Now we moved L1. So if L1 was here before at this 2, we set V1 to be L1.val, which is 2, and then we move L1 to be L1.next, which is the 4. Okay. Now if L2, we're going to do the same thing for V2. So we're going to set V2 to be 5, and then we're going to move L2 forwards. Okay. Awesome. Now, how do we tell if we have a carry? Well, if the number is greater than 10, then we have a carry, or greater than or equal to. So we have 6 plus 4, which is going to be exactly 10. And what I'm going to do is I'm going to take the value at L1 plus the value at L2 plus the carry and divide it by 10 to see how many times 10 goes into that sum. So V1, V2, and carry are all going to be summed, and then they will be divided by 10. So here you'll see 4 plus 6 plus 0, which equals 10. And divmod just gives you the floor division. It'll give you 10 floor 10, and it'll give you 10 modulus 10. So 10 floor 10 is 1, 10 modulus 10 is 0. So I'll get a 1 and a 0 from this divmod function. And if you were to do this by hand, add this 4 and the 6, you drop the 0 and carry the 1. So the first element is going to be the carry. Okay, so the first element is the carry. The second is the remainder. And that's what's going to go into your node. Okay, so here we get 10, we drop the 0, we put it in our node, we carry over the 1, which, you know, goes to this 3 and 4. Okay. Then we set n to be n.next. So n is going to look here. Or sorry, first we set n.next. I don't know why it doesn't undo. First we set n.next, to be this value. So we make a new node with that value in it, right? Then we move n over. And then that's it. Okay. Now we do the same thing. But our carry is 1, remember. Carry is 1 right now. So let's just do carry equals 1. I'll erase all of this junk so it doesn't get confusing. Okay, now what? V1 and V2 get set to 0 again, but then they get set to 3 and 4. So we have 3, 4, carry is 1, so 8. Our total is 8. 8 floor divided by 10 is 0. 8 modulus 10 is 8. Right, so we get 0 and 8. So our carry is 0, remainder is 8. All right. N.next is a new node with that 8 in it. And we set n to be that. Okay, and at this point, our carry is 0. So at this point, we are done. And we just return our root.next. But you'll notice this minor thing here. I did it this way. You can do it another way if you want. I started with root as an empty node. And then in the first iteration, n is pointing at root. So I'll say n.next is a new node with that 7 in it. And continue on from there. And then I'll just return root.next in the end. The alternative is you can have, you can put your 7 here and the 8 and the 0 here and the 8 here. But then in the last loop, you're going to create a node with a 0 in it. So you will have to delete that node before returning your root. So I just did it this way instead. And that's it. Thanks for watching.